All right, so just to review what we just went over, this question number 2 about dilation with center C and a scale factor of K, and it maps L to M and P to Q. So it's mapping LP to MQ. And so you can see right here that if the center is C, this is just an example, it's going to map it. And you know that it's a smaller, the pre-image is bigger than the image. So the mapping is MQ and it's shorter. And so it's 12. You put pre-image over image. I'm sorry. No, image over pre-image. Is that what the formula is? Image over pre-image. Image over pre-image. And that reduces down to 5/6. It can't be negative 5/6 because it's absolute value, as you can see there. And also it can't be bigger than 1 6/5. In this case, because it's a reduction, it's going from a size 12 to size 10. So you know it's a reduction, not an enlargement. Okay. Next question says, identify the similar triangles. Is that what we want? Number 9, identify the similar triangles.
Both of them.
Okay. So, well, we can see that this angle is on this triangle right here. And that angle is also part of this triangle right here. So notice it's part of 2 right triangles. You follow what I'm saying? So angle M is part of 2 different right triangles. And so the right triangles, the blue one, I'm going to write the blue one out. The blue one is going to be LMN. That's triangle LMN. And notice that I started with the right angle. This was the right angle. And so if I write is congruent to triangle, well, what's the right angle on the red triangle?
Q.
It's Q. So Q, and now let's go toward M again, right? QMP. So those 2 triangles are going to be not congruent. I'm so sorry. They're going to be similar. They're obviously not congruent. One's bigger than the other one, but they're similar because they have the same angles. They have a 90-degree angle and they have the angle M as a part of it. And so that third angle has to be equal to the other third angle. Does that make sense? So LMN is congruent to Q. Notice you have to make sure you write it correctly. So it's going to be B. LMN is congruent to QMP. This was my right angle. So was the L. M was the same on both of them. And then the other one is that third letter. Does that make sense?
Yep.
Now it says find LM. So they want us to find this distance right here. Well, we know that the ratio of 10 to 12 is going to be the same as, they're similar. So that ratio is going to be the same for PQ. Look at what PQ is. PQ is that one. So it's going to be NL. NL. So that's 15. 15 is to, let's make sure that that's the right thing. PM. Is PM the same? PM is this? Is it NL? Oh no, that's. Okay, so maybe I need to find something else here because that's not the one that I want. Well, we can still do this. So 10 is to 12. PQ is to QM. So PQ, which is the same as NL, is to QM, which is LM. Oh, wait, that is LM. Is that right?
Yeah, I was about to say.
That's right. Is that the right setup?
Yeah.
I believe that is the correct setup. Sometimes it's good if you redraw the triangles out on the side sometimes it helps you to see it better. So here's QPM, that's the red triangle. And here is QPM, so that's going to be LM, N. That makes sense? So drawing this out, this would be 12 and this would be 10. And we're trying to find LM. We're trying to find this one. And we know LN, we know this one. Oh yeah. Does that make sense? A little bit easier to see like that?
Yeah.
So now you can see, because you drew them, you kind of, oriented them the same way. You can see that 10 is to 12 as 15 is to X. So cross multiply. Let me show you a little quick trick here. 10X equals 15 times 12. Now don't multiply 15 and 12 together. That's a waste of time. Just divide both sides by 10 and cancel out what you know. Well, these both have a 5 in them, right? So if you cancel a 5 out of that, it would be 3. A 5 out of that would be 2. And these both have a 2 in them. So cancel a 2 out and you get 6. And all you have left is 6 times 3, which is 18. I call that simplify before you complicate. Don't complicate things. Don't make things harder to do. If you've already got them broken up into factors, just cancel out common factors. Does that make sense?
Yeah.
All right, so that was that page. Next, number 6. So they're telling us that LMN is similar to RST. So let's draw these out. LMN, and let's draw RST, a little bit bigger maybe. RST, make sure you're drawing them in the same places. And they're telling us that MN is 28. And the scale factor is 4/3. Find ST. They want us to find that. Well, that's easy. Just multiply 28 times 4/3. Now, let's do that trick I just showed you again. Simplify before you complicate. Whoops, that's not going to work here. Why is that not going to work?
Improper fraction.
It's not going to work because 28 doesn't have a factor of 3, right?
Oh, okay.
Did I just lose my, can you guys still see what I'm doing?
No.
Are you moving?
Not right now. Now I am. Yeah, you
Good.
can't see it.
Frozen. I don't see anything.
Yeah, it's frozen. Give me a second here. So I don't need to really simplify this except to multiply 28 times 4. Let's see, what's the easiest way to multiply those together? I'm basically trying to figure out which one of those. I mean, I'm guessing it has to be this one, right?
Yeah, that's the answer.
Because the other two, 28 times 4/3, 4/3 is 1 1/3. So I could think of it as 28 times 1 plus 1/3, which is 28 plus 28/3. And 28/3, 3 goes into 28 9 times with 2 left over, right? 28 plus 9 is 37. Whoops, with 1 left over, my bad. 37 and 1/3. But looking here, this is another little piece of advice for you. When you're taking a multiple choice test and you know you've got the right answer, sometimes you don't have to actually do the work because you know, well, that's not 28 times 4/3. That's not 28 times 4/3, and that certainly isn't. Because 28 times 4/3, that's got to be more than 28. You understand? Because whenever you multiply a number by a number bigger than 1, When you multiply a number by a number bigger than 1, that number is going to be bigger than the original number. Does that make sense?
Yeah.
So I knew none of these were the right answer. It had to be this one. And it was a multiple choice question, so I didn't even have to bother doing it unless I wanted to make sure I did it right. Okay.
Mm-hmm.
Next, determine whether the dilation from W to W prime is an enlargement or a reduction. W, so you can see that W prime is smaller. So you know it's a reduction. And it's a reduction. This is 22. And this is 14. Remember, it's the image over the pre-image. Sorry. Yeah, image over the original. So it's 14 to 22. I can cancel both of those by 7. No, I cannot. I can cancel a 2 out of both of those, which is 7 over 11. It's a reduction by 7/11. That's the correct answer. We good? Can I get a confirmation? Do we know the answer on this one?
I think that's not my question, but I think that's the right
Wait.
answer.
I'm kind of glitching up. Kind of confused.
Okay, so it says refer to this, choose the correct graph of a dilation of ABC centered at point D. There's point D up here with the scale factor of 2. So here's what that means. So choose the correct graph of a dilation of ABC centered at point C of a scale factor of 2. So A is going to go from here. It's going to go 2. It's going to be 2 times the distance, right? So it's going to go, let's see, since that distance was 1, it's going to be 2 away. Is that right?
Wait, why did you go down? Why didn't you go up?
Because the distance, it's from D. It's centered at D. So it's going to go straight through here.
What I thought it would go like, since it's A to D. I thought since it's 1 from A to D, then it would be a new point from D to A prime, which would be up 1 from D. That's what I was thinking.
No, I do not think so. I believe what you do is this. So here's the point. There's that point. That's A prime.
Okay.
And then you go and you do this right here. You go from D to C, and you go twice that distance. The scale factor of 2 means you double it. So you would go to there. So that's C prime. Did you follow?
Yeah, I follow.
Go from here to here. Go twice that distance. So notice what I'm just doing is I'm looking at the slope here. Over 3, down 3. So I'm going over 3, down 3 again. I'm doing that same thing to get that same distance. So over.
This one would be 7 negative 2.
Correct.
Oh, I see now.
B prime.
Okay, that makes sense.
And so that is your new. Whoops. No, I'm sorry. I drew that wrong. So your image, your image is actually, let me draw it yellow. This is your image. You see how it's twice as big?
Yeah, I see that.
Now, do you know the answer for this one? Let's make sure we're doing that right.
Yeah, the answer. Yeah, that is the answer. I put it in. All the answers I got were right.
Okay. So does that make sense how you do that?
Yes, sir.
Any other questions? Sumaya, do you have more questions?
No, for now, no.
Okay, stick around. Ian has more.
All I have this one.
All right, so quadrilateral ABCD is similar to quadrilateral W, etc. WXYZ, find the scale factor. Okay, so this is basically just going to be this and this. You're going from, so it's A, B, C, D to that. So basically what you're doing is you're saying 3 times what equals 3.75. So X equals 3.75 over 3.
And that's here. Let me put that in. 3.
So this would be like your image, right?
that-
And this is your pre-image.
So that's 1.25.
Correct.
Okay. And then, so it would be the same thing for, or no, it would be different.
No, should be the same. So if you mean for this one, if you did 6.25 divided by 5, you should also get 1.25.
Oh, okay. But what
And if-
about this one that I just pasted?
And by the way, if you do 5 divided by 4, you should get 1.25, which you will. 1 and 1/4.
Okay.
So this is the same kind of question.
Yeah.
Oh, I'm sorry. This is not the same. This is just telling you that they're similar.
So I just want to make sure. So if they're similar, right?
Well,
So
then
that's
I mean,
that still
they didn't
means-
even have. Honestly, they didn't even have to tell you that they were similar.
Like, I just wanted to make sure. So like, even if it's flipped like this, they're still the same angles, right?
Yeah, they didn't even have to tell you that they were
I just
similar.
wanted to make sure, like, I'm not like missing some, random formula that I misread or something.
Well, the formula is that you know that the angles of a quadrilateral. You know what the formula for that is? How you find the angles of a quadrilateral? Think about it like this. If you draw a line from one of the vertices, you just turn that into 2 triangles, right?
Yeah.
And each triangle has 180 degrees in it.
Right.
So what you have is 180 degrees times 2, which is 360 degrees. That's the total number of degrees you have in a quadrilateral. If it was a pentagon, you could do the same thing, start from any vertex and turn it into triangles, break it into triangles. Notice how many triangles you have.
3.
You have 3, and each triangle is 180 degrees, right?
Yeah.
So the number of angles is 180 times 3.
Oh, okay. So wait, so then would it be for the same thing for 6? It would be 4 triangles. For 7, it would be
That's
5
right.
triangles.
That's right.
Oh, so it just keeps rising and rising.
That's right. So it's n minus 2 times 180. That's the formula.
N minus. Wait, let me write this down.
The formula of the number of angles, the total number of angles in a polygon is
Yeah.
n minus 2, where n is the number of vertices.
Okay, I got that one.
Okay.
So
I don't know-
then, yeah,
I don't know
we
if you've
know-
technically learned that yet, but that's something that you need to know.
We know the answer is 95, then.
Yeah, but for this one, they didn't even really have to tell you that. You could just tell.
Yeah, you could just tell, like, they just flipped it over. It's not pretty obvious. One.
Right.
Okay. I'm just going over everything because I just want to make sure, like, I know everything right.
No
Like,
problem.
I want to make my concepts like 100%.
Yeah, that's a good idea. Where are you pulling these things from, by the way?
Oh, these are all from the homework.
Okay, sounds good. All right, so this question says, architecture on the floor plan for a building, 1 inch represents 20 feet. If the dimensions of the room of the plans are that by that, What are the actual dimensions? Well, it's 1 to 20, so you literally just multiply each of these times 20. Multiply that by 20, and that's going to be your or whatever, or one dimension. And multiply this by 20. That'll be your other dimension.
Wait, so you if the dimension of the wait, I don't understand why you did that.
Well, because 1 inch represents 20 feet. So think of it like this. If it's 0.875 inches, think of it like conversion factors.
Oh, so it wants
If
to know
1 inch equals 20 feet, now you've just converted that from inches to feet.
oh, so this just wants us to tell us the same thing but in feet.
In
That's
feet.
what it
That's
wants?
right. Yep.
Oh, okay.
So the actual dimensions of the room are whatever 20 times 0.875 is.
Put that in 1 second. So 0.875
Probably 17.5.
20. So you get 17.5 by 25 feet as your answer.
There you go.
Okay.
For this one, they're telling you that RST is similar to UVT. So you know that RS is well, since these are similar, you know that proportions of the sides are equal to each other. Meaning let's see. RST here, let me draw these in so we can see it better. RST, that's this red one, is similar to UVT, similar to this blue one. So that means that proportions RT, whoops, dang it, hold on. That means that RT is to I think
UT R S T.
This is kind of like the dilation. One is a dilation of the other. You could think of it like that. So RT is to UT, or I could flip that upside down. Notice they're putting the UT on the top because it's smaller. So I'll do that too.
Wait, so you're saying UT is half of RT?
Not necessarily half of it, but whatever the ratio is, whatever the dilation is of that, UT is to RT as
SR is the
as
U.
UV is to RS or SR.
Yeah. And then VT is the ST.
Right? That's right.
Oh, I see. All right, that makes sense.
So that would be the statement. I'm looking at the other ones, why the other ones might be wrong. UT is to RU. No, that's definitely not true because this is not to that. That is not true at all.
Wait,
RT is to RS as ST is to RS, definitely not. Now this is the one RT is to RU. Oh no, definitely not that either.
Wait,
Yes,
Mr.
definitely
Dwyer.
not any of those. Yes.
I know that one's right, but it says that the first question that we did with the quadrilateral ABCD and stuff, how we did 3.75 divided by 3 equals 1.25. So that's saying it's wrong. That's not the scale factor.
Which one?
The with the
Mhm.
quadrilaterals that we did A, B, C, D is the quadrilateral W, X, Y, Z. Find the scale factor.
This one.
No, I think it's 1/.
Then?
Yeah, that one. No. Go one back. This one. So we said it equals 1.25, but it says 1.25 is wrong.
Okay, hold on. Maybe we read this wrong. Find the scale factor of A, B, C, D. That's the smaller one. 2 quadrilateral W, X, Y, Z. Okay, so maybe they're saying that, maybe what they're saying is that ABCD is the image and WXYZ is the preimage.
Wait, it's similar to.
Kind of worded strange.
Oh, I think it's saying ABCD is similar to quadrilateral WXYZ, which means XYZ was the original.
Okay. See, I didn't read it that way. I didn't read it that way, but that must mean that this is the preimage.
Oh, so we just did it the other way around.
Yes. So the answer is going to be 4/5.
Yeah. Okay, that makes much more sense. That's such a weird way to word it.
It is weird. It is weird. I didn't read it that way. It says find the scale factor of that to this. So they must mean that this is the original and this is your preimage and this is your image.
Exactly.
So I guess when they word it like this, they give you the image first.
Okay, so when it says similar to, that means that the one that is saying it's similar to, that's like that came off of the one that it's similar to.
Maybe, yeah, maybe that's what they mean maybe that's what they mean, but that's not how I read it. But that's fine.
Would that be the case for everyone then?
I don't know. I guess I would yeah, that's a good question.
Because then I don't want to go and do a test and then it says, oh, this one's similar to this, and I'm sitting there confused. Which one do I do?
Right. Yeah, I suppose so. I suppose hopefully they'll use the word image and preimage or mapped to. Hopefully they will say ABCD is a map of WXYZ, and then you'll know that WXYZ was the preimage.
Yeah, I guess. I mean,
Or they'll say you map the map takes W to A, something like that. I hope they give you some sort of indication because, again, they didn't make that very clear on this. But maybe in the notes they talked about that. Maybe in the
no,
book.
I mean, in the notes they were just worded that way, and then I did the equation and it was right.
Yeah. I don't know. Yeah, I guess if you ever see something similar to this, you can just point back to this and you can even talk. You know, if you get it wrong, you can talk to your teacher about it. Just request, hey, they didn't make it clear which one was a preimage. Mr. Dwyer and I talked about this during office hours. Can you go talk to him and he'll vouch for me, and I'll definitely vouch for you. Find the value of y in the figure. So you know that these are similar triangles. So you know 6 is to 9 as y plus 3 is to 12. That makes sense?
Wait, is it because of the right triangles?
Well, because, yeah, you know they have to be similar because you know those are equal to each other. And so you know that these ones have to be equal to each other. So they're similar triangles, which means they're proportionate. So this side is to this side as this side is to this side. Or like I wrote, this side is to this side as this side is to this side. You could do it either way.
So, wait, so why'd you put the 6
you
on
what
top?
else.
Why'd you put the 6?
Or you could have written it like this. 6 is to y plus 3 as 9 is to 12. It'll give you the same answer because you're going to cross multiply.
Oh, okay, okay.
6 times 12 equals 9 times y plus 3. Or for this one, cross multiply, you get 6 times 12 equals 9 times y plus 3. Now, let me teach you another trick here, or reiterate the same trick I was telling you about. So these are the same problem, right? So instead of multiplying 6 and 12, don't do that. Don't waste your time. Divide by 9, divide both sides by 9, and cancel out. See how they both have a 3? Cancel the 3 out.
I see
Yeah.
that.
See how these both have a 3? Cancel the 3 out.
Okay.
So this is just 8 equals y plus 3. And now subtract
That equals 5.
3 from both sides. Exactly.
Okay, so I can do it any order. Okay, that makes sense.
No, that's just called being smart. I don't want to use my calculator. So that's called simplify before you complicate by Mr. Dwyer. Why multiply this together and get 72 and then multiply this and then, what is that? 27? And then subtract 27 and then divide by 3. I mean, that's such a waste. You know what I'm saying? Just take that 9, divide it by both sides, cancel it, because you know that in this case, the factors cancel the factors, and boom, you could do that no problem without even using a calculator. You could practically do it in your head.
Yeah,
Yep.
that in my head as well.
Any other questions, guys? So which one of the triangles is not similar to the others? Well, you can tell by using, first of all, let's make sure they're all oriented the same. Is the smallest side on the right? Yes, it is. Is the biggest side on the bottom? Yes, it is. Okay, so we've established that. Now let's just look at the ratios. Is 5 to 9 the same as looking over at the one on the right? Is that the same as 6 to 12? Is that the same as 8 to 16? Is that the same as 4 to 8? Which ones are the same? Well, definitely 5 to 9 isn't the same. These are all 1/2, right?
Oh, so then that means W is not similar.
So the one that's not similar is W.
Okay, that makes sense.
So for this one, you want to figure out, let's make sure they're all oriented the same way. Let's put the biggest angle on top, or let's color the biggest angle with red. So those are the biggest angle, right?
Yeah,
Let's color the smallest angle with yellow.
that would be the right.
Well, hey, how about that? And the smallest angle for that one is here. So clearly, is it clear which one is not the same?
Yeah,
Which one?
it's LKJ.
Right. I mean, you could do the math on it and subtract them, but you'll find that this is the other angle has to be 38. The other angle here has to be 50. The other angle here has to be 92. And that angle doesn't make sense.
Because that's bigger than both of them.
That would be 48. That's right.
Exactly. So then JK, LJK.
That's correct.
Okay.
All right. So this says a bush casts a shadow 8 yards long. At the same time, a tree casts a shadow. So let's make the tree here. There's the tree. And here's the bush. Now, the assumption is that the sun, which is way far away, it doesn't matter where the angle of the rays is going to be the same angle. So basically what we have is this shadow right here of the tree is 20 yards. And the shadow of the bush is 8 yards.
Wait,
So those angles are the same basically. So what I can do is I can put the bush over here so that this distance is 8 yards right here. That makes sense?
Wait, so
20
wait,
yards is the full distance.
but wait, that is 20 yards high.
Oh, my bad. Sorry. I'm misreading the question.
So should
36 yards.
36 be on the bottom and then 20 yards on the top?
Yeah, 36 yards is right there. Thank you. Sorry about that. And you know that this distance up here is 20. So my triangle, let me get rid of this other bush. So my triangles are basically this triangle right here, which is 20 by 30, 20 high and 36 long. And then this triangle right here, which we have to find X, the height, and it's 8. So again, you set up a proportion. You know that 20 is to 36 as X is
to
to
8.
8. And simplify before you complicate. I'm going to show you how I do that again. So 20 times 8 equals 36 times X. Divide both sides by 36. In fact, if you want, you could break 36 up. What does 36 equal?
I'm not sure off the top of my head.
2 and 18?
Oh, wait, yeah, right.
Just to see it a little bit better, right? So let's take the 2 out of the 20, and that becomes 10. Let's take another 2 out of the 10, and that becomes 5, and that becomes 9. And can I reduce anything else? Does 9 have anything in common with 8 and 5?
No.
No, so it's 40 over 9. And I guess we needed to use, we might as well just punch it in because it's a decimal answer.
Yeah.
40 over 9, so 9, well, I can show you this too. 9 goes into 40 how many times?
6 times.
Nope.
9 times 6 is
4
30.
times.
Oh wait, no, sorry. 9
And-
times 4 is 36. Sorry.
Right, and there's 4 left over. So 4 and 4 ninths. And 4 ninths is the same as 0.4 repeating. You don't even need your calculator for that.
So you just need 4.4444. So it'd be 4.4 yards.
That's it.
Oh, okay.
No no calculator needed. So the correct answer here is this one right here. So if I take this triangle and it's 60, 60, 60, 60 degrees on each, and I put that on a transparency, and I project it up to the wall, what I project up to the wall is going to be a lot bigger. It's going to be a much bigger triangle. Like the lengths are much bigger, right? But it's a similar, I'm not going to say the same, it's a similar triangle because the ratio of side lengths, this side to this side, is the same as this to this. The ratios of side lengths are the same in similar triangles, which means they are proportionate. That's what it means to be proportionate. Does that make sense? So let me do another example. If I take, and again, this is kind of the main takeaway from this whole chapter. If that triangle is similar to, I'm going to draw another one right next to it, but those angles are all the same. So this, let's say that these angles are all, what does this look like? 70, and this looks like 60, 70 plus 60 is 120. So what's this, 60 also? Did I do that right?
Yeah.
50. Don't lie to me. Is that right now?
Oh wait, did you draw a 5 or a 6? I don't have my glasses.
Yeah, it was a 5. There was a 6. It should have been.
Never mind. I'm wrong.
Anyway, you see those two triangles? Are those congruent triangles? Are those two triangles congruent?
I mean, we don't know the sides.
Does it look like they're congruent?
No.
Not at all. One's way bigger than the other, right? You follow what I'm saying? Those aren't congruent, but if this is X and this is Y and this is Z, and this is A and this is B and this is C, what we do know is that X is to Z as that ratio is equal to A divided by C. That's what we know. And this, by the way, is called a proportion. This is called a proportion. And we say that triangle XYZ is similar to triangle ABC, and they are proportionate. They're proportionate. That's what that means. It means that the ratio of side lengths are equal to each other. You could also write it like this: X is to A as Z is to C. You could also write it that way. That's another way you could write the proportion. But these two things are called proportion. You can write it either way. And there's other proportions you can write with these side lengths, but that's what it means. They're not equal to each other. X doesn't equal A. You understand?
Yeah.
But the proportions are the same because
The
this is
ratio
this is
congruent.
an enlargement. This is an enlargement. A dilation. That's a dilation. It's a dilation. Sorry, I'm saying that wrong. And more specifically, it's an enlargement. So what I'm doing is I'm taking X and I'm multiplying it by some constant K, and I'm getting A. Why? Because A divided by X equals the same constant. That's the constant of proportionality. You understand?
Yeah, I understand.
That's the constant of proportionality. And it's the same constant as I would get if I took B and divided it by Y. That's the same K. And it's the same constant I would get if I took C and divided it by Z. That's the same constant of proportionality.
So if that ratio, if the angles are all the same, that the ratios are always congruent.
By the way, I don't have to write, I wrote something wrong. I don't have to write it that, I don't have to write the is congruent to, I write equal to, because those are numbers. Those proportions are equal to each other. They're not congruent to each other. They're equal to each other. I made a mistake by writing that little congruent symbol over.
Wait, is congruent only for shapes?
Yes, congruent is not, congruent is for triangles. You can talk about triangles being congruent. You can talk about angles being congruent. But when we're talking about proportions, ratios of side lengths, those are equal to each other, not congruent to each other.
That makes sense.
A little bit of a tricky, it kind of means the same thing, but it's technically not the same thing.
Yeah.
I may not have said that exactly right. You might want to check.
No, but I get what you were saying.
Look that up, but I shouldn't use congruent for these things here. So do you see how all three of these are all, because if I take this is a projection, and what do they call that again? The constant of proportionality, or they call the I forget what they call that. When it's dilated by a factor, that's what it is, the factor. So this is dilated. XYZ is dilated by a factor of K. So another way I think you can hear people talk about it is a XYZ. I'm sorry, ABC is a dilation of XYZ by a factor of K.
Yeah.
That makes sense?
Yeah, that makes sense.
So that's kind of like, now that we did those practice problems, that's kind of like a re-explanation for you of what this unit is all about. Dilations and similar triangles and proportionalities and all that kind of stuff.
Right.
Okay, all good?
Sounds good. Is it cool if I? Is it cool?